All right, guys, today we are going to continue solving systems of equations. We've been introduced on how to solve those systems graphically, where we essentially just graph each linear function and we look for an intersection point. That intersection point represents the solution, which again is a combination of x and y that makes both of those equations true. Now, obviously, we're not going to want to graph every single one of these. It would take a lot of time. It would require us to graph every single time, which I know that you guys don't exactly like. So our objective for today is to use a new method, which is called the substitution method of solving linear systems. Objective, solve systems of equations using that substitution method. I think you guys are going to like this a little bit more than just graphing. So the substitution method is a process that involves substituting a certain equation or a certain expression into the other equation so that we can solve this a little bit more algebraically. Substitution method requires no graphing. And the process is to solve one of the equations for either x or for y, okay? And this may already be done for you, and what I mean by solve is, as we've talked before in solving different equations, you need to get that x or y all by itself and set it equal to something, all right? Step 2 is to substitute that expression into the other equation and solve for the opposite variable, okay? Hint for you, and what I call these are island x's or island y's, which basically just means like an island, it's all by itself. And you guys will see once we get into some examples what we mean with this. So the first system we're going to solve is y equals 3 times my x, and then x plus y equals negative 32. So we're looking for a combination of x's and y's that, when added together, get us negative 32. And our x value, if we multiply it by 3, is going to get us our y value. So the method of solving by substitution, again, we're looking for those island x or y terms. And right now I see an island y value right here. Like I said, y, or this process might already be done for you. So if I see the y all by myself, what we're going to do is we're going to say, what is y exactly equal to? Well, in this case, y is equal to 3 times my x. So the substitution that happens is we take that 3 times x and we substitute it into the opposite equation wherever we see a y. So in this case, we're going to replace or substitute y with 3 times my x. What this does is turns this into just a 1 variable equation instead of a 2. So when we write this process out and you substitute, this second equation is now just x plus whatever we substituted, which was 3 times x. Again, that was what used to be y and is now 3x, is equal to negative 32. And then we've got an equation with just 1 variable. We can take the x terms, put them together to get 4x equals negative 32, and use some mental math calculations or just show our work, divide by 4, and get x equals negative 8. So this is the value of x. And after we get 1, it's pretty easy to come up with the others. All you got to do is actually resubstitute that value into either of the top 2 equations, or either of the original equations, and just solve for the unknown value. In this case, I'm going to substitute my x value, negative 8, into this top equation because it'll make it a little bit easier. I'm going to say y is then equal to 3 times my negative 8, and my y value's got to be negative 24. And you think about it, and you got a lot of markings going on, but if you look at the original equations, y equals triple my x. So 3 times negative 8 gets me negative 24, that works. And then negative 8 plus negative 24 gets me negative 32. So it's just a way to solve these things a little bit more algebraic. Let's look at another in practice, solving this using the substitution method. If you'd like to, you can pause the video and work on this. First thing I'm going to see is that both of these equations are solved for y. They're both in slope-intercept form, which makes it easy because then we can identify, and I always just put a box around something that I'm going to substitute. I'm going to take this x minus 1, I'm going to substitute it into the top equation wherever I see a y. So this turns this equation into x minus 1 is equal to 2 times x plus 7. This is an equation that just contains 1 variable. We can solve it by first adding 1 on each side and getting x equals 2x plus 8. Then to get my x terms on the other side, I would probably want to subtract 2x on each side. Kind of going about this in a weird way, but that's okay. And I'll get negative 1x is equal to 8, which means a positive x is equal to negative 8. Now, once I've done this process, I'm not quite done yet. I take x equals negative 8. I substitute that into one of my top equations. I'm going to put it right there. And I would get y equals negative 8 minus 1 or negative 9. Now, this represents the coordinates in which these two graphs would intersect. X equals negative 8. My solution would be written as a coordinate, negative 8, negative 9. This is my solution. All right. Practice one more. Solving using substitution. Now, as we said before, sometimes the equations are already solved for y or x, and sometimes you might need to do a little work with them. This example, I see that I've got an island x term right here. I think I'm going to try and solve that for x. And before I do so, I'm going to rewrite this equation just as 2y minus 1 equals x. And really all I did there was just subtracted 1 on each side to get x by itself. And once we've done that, take whatever x is equal to, substitute that value into the other equation. Wherever you see an x, I'm going to put it right there, and then we just simplify. This is negative 2. Notice we're substituting an entire expression in this one, which makes it a little bit trickier, is equal to 2y minus 1. And then we got to subtract y is equal to 7, and now we just need to simplify the equation and solve it. I would distribute my negative 2 times 2y, negative 2 times negative 1, get, that looks like a negative 4y plus 1, since we have negative times a negative, and then minus y equals 7. We've got terms that we can combine. Our negative 4y and our negative 1y can combine to make negative 5y's plus 1 is equal to 7. I think our answer here is going to be a nasty number, but that's okay. Subtract 1 on each side. We get negative 5y equals negative 6. So y must be equal to, let's see, if we divide this by negative 5, divide this by negative 5, we get y equals to 6/5. Which is kind of a gross number, but that's okay. That's part of our solution. 6/5. Y equals 6/5. And then plug that value into the other equation to solve for x. I'm going to take that and plug it into this top equation. 2y equals x plus 1. And I would get 2 times 6/5 is equal to x plus 1. Double 6/5 gets me 12/5 equals x plus 1. And when I subtract 1 from this and subtract 1, I'm going to write that as just 5/5, which is the same as 1. My x value is then equal to 7/5. So we got 6/5 and we got 7/5. X equals 7/5. Which, as I know, is not a very nice number, but sometimes your answers aren't so nice.